Yeah, welcome back everybody. We continue with partial fractions and we're taking a few more examples on improper fractions. So let's go straight to it. Let's take this. How do you resolve this into partial fractions? I think I want to start with this: x squared plus 1 over x plus 2 all squared. How do you resolve this into partial fractions? First of all, before you resolve any fraction into partial fractions, you must check if that fraction is a proper fraction or an improper fraction. So let me expand this denominator. X plus 2 squared is the same as, if you expand that, the square of x plus 2 is the same as x squared plus 4x plus 4. So that means, yeah, that's what this one is. So that means the degree of the numerator, the degree of the denominator is 2, pardon me, and the degree of the numerator is also 2. We already talked about how to determine the degree of a polynomial. That simply means this is an improper fraction because the numerator and the denominator have the same degree. So the first thing to do is to reduce it to a proper fraction. So I want to write this as x squared plus 1 over x squared plus 4x plus 4. Now, to reduce it to a proper fraction, I have to divide the numerator by the denominator. X squared plus 1. There's no x term in this, in the numerator, so to avoid confusion, let me just write 0x plus 1. And I'm dividing that by x squared plus 4x plus 4. So let's go. As usual, x squared divided by x squared is 1. So we multiply the whole of this by that 1. And that simply means x squared plus 4x plus 4. Now we subtract. X squared minus x squared is 0. 0 minus 4x is simply minus 4x. 1 minus 4 is minus 3. Now the degree of minus 4x is smaller than that of x squared, so we can't divide further. We just stop there. And that simply means x squared plus 1 over x squared plus 4x plus 4 is the same as, like we did in the last example, you just write the quotient, which is 1, plus, and form a fraction, which is the remainder over divisor. So that's plus, let me write it this way, minus 4x minus 3 over x squared plus 4x plus 4. I know that x squared plus 4x plus 4 is the same as x plus 2 squared. So let me write that. So that means x squared plus 1 over the square of x plus 2 equals 1. Of course, this is the same as saying plus, open bracket, no? Let me write it this way. Minus into bracket 4x plus 3 over, this denominator is the same as the square of x plus 2. Yeah, so I can write it that way. So that means 1, if I open the brackets now, it's going to be minus 4x plus 3 all over the square of x plus 2. Yeah, that's it. So now I've reduced the improper fraction into a proper fraction. So this is what I will now resolve into partial fractions. I just want to resolve Now I want to resolve 4. Let me write this here. X plus 1 over the square of x plus 2 is equal to that. So now I want to resolve this into partial fractions. I want to resolve this into partial fractions. 4x plus 3 over the square of x plus 2 will be equal to, now in this case we can see that this factor, the factor x plus 2 is linear, but its power is not 1, or its exponent is not 1, it's greater than 1. Whenever the exponent of a factor is greater than 1, that factor is called a repeated factor, whether it is a linear factor or a non-linear factor. If it has an exponent that is greater than 1, then you say it's a repeated factor. And this is how you resolve a fraction with such a factor into partial fractions. So that's going to be, it's a linear factor, so the numerator of its partial fraction will be a constant 2. But this is what you do. A over x plus 2 plus, this is just like saying a over x plus 2 raised to power 1 plus b over x plus 2 raised to power 2. So that's what you do. If it's 3, you say a over x plus 2 raised to power 1 plus b over x plus 2 raised to power 2 plus c over x plus 2 raised to power 3, and so on. So, but I don't know whether I put the 1 or not, it's still the same. So this simply means, let's find LCM. LCM is still the square of x plus 2. Now x plus 2 divided by x plus 2 is x plus 2, so that's a into bracket x plus 2 plus x plus 2, the square of x plus 2 divided by the square of x plus 2 is 1 times b, that's b. So that means 4x plus 3 equals a into bracket x plus 2 plus b. Now if I put x equals minus 2, this will be 0 and I'll be left with b. That means 4 times minus 2 plus 3 equals b, which means minus 8 plus 3, that's minus 5, equals b. And that simply means b equals minus 5. Now to find a, I can just put x equals 0. So that means 4 times 0 plus 3 equals a into bracket 0 plus 2 plus b. And that means 3 equals 2a. 0 plus 2 is 2 times a, 2a plus b. Which means I already know b. b is minus 5. That means 3 equals 2a minus 5. If I bring the minus 5 to the left hand side, it becomes plus 5. So 3 plus 5 equals 2a, and that means 8 equals 2a. When we divide, if I divide both sides by 2, a will be equal to 4. So that simply means 4x, let me copy that fraction. That means 4x plus 3 divided by the square of x plus 2 is equal to a over x plus 2, which means 4 over x plus 2 plus b over the square of x plus 2. This is called repeated linear factor. Now we have resolved that part of the original equation into partial fractions. So that simply means this, what do I do now? And that simply means the whole of this is the original equation. That simply means the whole of this this was what we got when we reduced the fraction to a proper fraction. And now we have resolved this one alone into partial fractions. So we just replace it with its partial fractions. So that means it is equal to 1 minus let me open brackets that way, 4 over x plus 2. What's b? I didn't do the right thing here. I wrote plus b over x plus 2 squared instead of the value of b. B is minus 5, so that's supposed to be, so plus minus 5, plus times minus 5 is going to be minus 5, so that's supposed to be minus 5 over x plus 2 squared. Sorry about that. So now that simply means 1 minus 4 over x plus 2 minus 5 over x plus 2 squared. Space doesn't look enough. And that's simply, I can open the brackets now. Let me delete this here. So I can open the brackets now, and that's 1 minus 4 over x plus 2 plus, of course, minus times minus is plus, plus 5 over the square of x plus 2, the square of x plus 2. So that's it very, very simply. It simply means x squared plus 1 over the square of x plus 2 is equal to 1 minus 4 over x plus 2 plus 5 over the square of x plus 2. Yeah, that's it very, very simply. That's it very, very, very simply. Let me see if we can take just one more example. Just one last example. Let's take that. X squared over x minus 1 squared. This is the same as, I can see that, of course, if I expand this denominator, I'm going to get x squared minus 2x plus 1, which means the degree of the denominator is 2 and that of the numerator is also 2. So we have established that this is an improper fraction. So we only need to divide to reduce to a proper fraction. How do we do that? We divide. Let's divide. Okay, let me write this. X squared over x squared minus 2x plus 1. Now I want to divide the numerator by the denominator. X squared. Let me write plus 0x plus 0. Since it doesn't have any constant and an x term, divided by x squared. We always do this just to avoid confusion. Minus 2x plus 1. X squared divided by x squared is 1. We multiply the whole of this by this and we get x squared minus 2x plus 1. Now we subtract. X squared minus x squared is 0. 0 minus minus 2x is 0 plus 2x. Of course, minus and minus is plus. So that will be 0x plus 2x, which is 2x. 0 minus times plus is minus. So 0 minus 1 is minus 1. The degree of this is less than the degree of x squared. So we can't divide further. That simply means x squared over x minus 1 squared. That's the same as x squared minus 2x plus 1 is the same as 1 plus 2x minus 1 over x minus 2x plus 1. But I'm writing x minus this square. I'm writing this one as the square of x minus 1. So that's 1 plus 2x minus 1 over the square of x minus 1. So now we have, I hope I'm doing the right thing here. So we can now resolve this. This is a proper fraction which can be resolved into partial fractions, and that's what I'm going to do. 2x minus 1 over the square of x minus 1 is going to be equal to a over, it's a linear factor but at the same time repeated, so that will be a over x minus 1 raised to the power 1 plus b over x minus 1 raised to the power 2, the square of x minus 1. And that simply means the LCM remains the square of x minus 1, so that a times the square of x minus 1 all squared divided by x minus 1 will be x minus 1, and we multiply that by a plus x, the square of x minus 1 divided by the square of x minus 1 is 1 times b, that's b plus b. So that means the numerator 2x minus 1 minus 1 on the left hand side, the numerator 2x minus 1 on the left hand side is equal to the numerator a times x minus 1 plus b on the right hand side. So if I put x equals 1, I'm going to get 2 times 1 minus 1, this will be 0, equals b. 1 minus 1 is 0 times a, that will make the all of this 0. So that simply means 2 minus 1 is 1, 1 equals b, which means b equals 1. Now what do I put to get a? Let me just put x equals 0. That means 2 times 0 minus 1 equals a into bracket 0 minus 1 plus b. And that means my battery was running out. Yeah, that means 0 minus 1, which is minus 1, equals minus a plus b. And that means minus 1 equals minus a. I already know what b is, plus 1. I already know what b is. That's plus 1. So I bring minus a to the left hand side and it becomes plus a. And I'll take minus 1 to the right hand side, which becomes plus 1. So a is equal to 2. That therefore means 2x minus 1 divided by the square of x minus 1, which is a over x minus 1, will be 2 over x minus 1 plus b over the square of x minus 1, which is, what's b? b is 1, that's 1 all over x minus 1 x minus 1 all squared. So we can now write the final answer. That simply means this fraction which was given originally, I'm going to copy it from here. That means this, I'm even copying from here. Let me copy from here quickly. That means this already x minus 2x plus 1 is the same as the square of x minus 1. So let me just write that. So we now replace this with this. So that simply means the original equation, which is x squared, which is this, is going to be equal to 1 plus 2 over x minus 1 plus 1 over x minus 1 all squared. And that's it, very, very simply. That looked a bit clumsy, but it's a piece of cake. So that's it simply. We have said that before you resolve into partial fractions, you must check to be sure of the type of fraction you want to resolve. And it is the denominator, the factors at the denominator that you check. Once you're able to determine what kind of fraction it is, it's going to be easy to resolve it into partial fractions. And the types of fractions are just a few. The ones with linear factors, the ones with non-factorizable factors at the denominator, the ones with repeated factors at the denominator, and improper fractions. So that's it, very, very simply. Thank you very much for your time, and I'll see you in the next. Bye-bye.